Okay. Coles conducts research. Coles does not. Woolworths conducts research. Woolworths does not. Okay, very quickly. If Coles researches, what should Woolworths do? Woolworths should research. Why? Because 20 is more than 10. If Coles does not research, Woolworths should choose research because 30 is more than 20. If Woolworths chooses research, Coles will choose research because 20 is more than 10. If Woolworths chooses not to, Coles will also choose not to because 30 is more than 20. I'll let you ponder on that. Look how amazing it looks. I'll give you a minute to work out the Nash equilibrium. What do you think is the Nash equilibrium for this game? Think about what we do know as a start. What do we know will definitely happen? Do we know something that will definitely happen? Is there a definite based on our analysis? Ooh, that's jumping a few steps. Anything more basic before that we definitely know? How do you know that? In both situations, Woolworths definitely will research. So what do we say? Woolworths has a dominant strategy to research. So in this analysis, we've analyzed each of the possible 4 moves and counter moves, and we can see that Woolworths will definitely research. So that's a certainty. So, if Woolworths will definitely research, what is the Nash equilibrium? Of the 4 moves, which one should we look at? Woolworths definitely researches, right? And what will Coles' counter move be? They will definitely, if Woolworths researches, Coles will research. So we say that this is the Nash equilibrium. Both firms researching is the Nash equilibrium. Both firms researching is the Nash equilibrium here. And we got that from looking at the third line. Why did we look at the third line? Because we got that Woolworths has a dominant strategy. So the actual equilibrium would be this. What if they worked together? What would they have chosen? If they worked together, what would they have chosen? That's a tricky one, isn't it? Would Woolworths prefer 2020 or 2030? It's hard to say, right? You could argue saying, oh, Woolworths might prefer 2020 because why should I give Coles another 10 and agree to 2030? But they may agree to 2030. So it's actually hard to say what the collusive outcome is in this case. You could argue both ways. So I can't say what the collusive outcome is. So there is... Oh, no, exactly. There might be no collusive outcome. So you could say, because they might not agree on 2020 or 2030, there might not be a collusive outcome. So it's hard to say what they would agree to. They would definitely not agree to these two. These two, they may agree to either of them. It really depends. If Woolworths is worried about that extra 10 to Coles, and that might make them bigger and that'll not kick them in the future, they might not actually agree to that. If they're not really worried about that extra 10, they may actually agree to this. So, that would be the straightforward way. So an easy way would say that's the collusive outcome because it adds up to more. But you could argue that, but then would Woolworths actually want that extra 10? So it's hard to say whether that's a prisoner's dilemma or not because of that issue. Okay. I'll do this really quickly because you're probably bored of me saying if this one does this one, if this one does that one, if this one does this one does that one. So I'll write really quickly. So we've got Coles, study, Coles, sleep, Woolworths, study, Woolworths, sleep. Okay. If Coles studies, what should Woolworths do? Woolworths should study. Why? Because 20 is bigger than 10. If Coles sleeps, Woolworths should sleep because 30 is bigger than 20. Does Woolworths have a dominant strategy? No, because the strategies are not the same. If Woolworths studies, what should Coles do? Coles should study because 20 is more than 10. If Woolworths sleeps, Coles should sleep because 30 is bigger than 20. Does Coles have a dominant strategy? No. Neither firm has a dominant strategy. So this game is a bit different. We can't work out what they will do for certain, because in this game, neither has a what? Neither has a dominant strategy. Now, what is the definition of a Nash equilibrium? One where you both choose what is best given what the other chooses, and the last bit was, and neither has an incentive to change. So we've got to analyze this one a little bit differently. So let's do the first line. If Cole studies, Woolworths will study. Now let's see whether Coles will change their move. When Woolworths studies, Coles will continue studying. So we can say that study is one possible Nash equilibrium. The way I followed it was this. So you go Coles studies, Woolworths studies, and then you jumped here to Woolworths study. So you take it here now, the orange line. Now Woolworths is studying. Is Coles going to continue studying? Yes. So we can say that study is a Nash equilibrium. The logic is this. When Coles studies, Woolworths studies. So then we look at, okay, now that we know that Woolworths is studying, is Coles going to choose something else? No. They continue studying. Therefore, that's one possible Nash equilibrium. Now let's look at Coles sleeping. If Coles sleeps, Woolworths will choose to sleep. So now I jump to Woolworths sleeping. When Woolworths sleeps, what does Coles choose to do? Do they change their original move? No. They continue sleeping. Agree? So we started with Coles sleep, then Woolworths slept, and now we look at Woolworths sleeping. Coles continues to do what they were doing before. So sleep is also a possible Nash equilibrium. So this game obviously has two Nash equilibria. When Coles chooses to study, Woolworths chooses to study. When we go to Woolworths choosing to study, we look at, okay, does Coles alter their original move, which was study? No, they didn't.
How do you write that though? To say?
Yeah, just write it in words. So you say, when Coles studies, Woolworths chose to study. And when Woolworths studies, Coles continues to study, which was the same move as before. They haven't changed their move, which is what a Nash equilibrium, because equilibrium means something stable, right? It doesn't change. So they continue choosing that original move. Even the sleeping, when Coles sleeps, Woolworths chooses sleep. And when you look at Woolworths choosing sleep, does Coles change that move? No. They continue with the sleep that was chosen before. This one makes more sense when you look at game 4, which is where they do change their move. So contrast game 3 with game 4, where the firms do end up changing their moves. So Coles jump.
Game 3, you have to figure out
Yes, I'll come to that in a second. Woolworths jump, Woolworths sit. Can we work out a collusive equilibrium for game 3? Yes. If they both worked together, what would they choose? They would both choose to sleep. If they were to work together, they would both choose to sleep. Is it a prisoner's dilemma? Can't say, because there's 2 Nash equilibria here. So we can't say. Okay. If you're confused about game 3, looking at game 4 should help. Okay. If Coles jumps, what's the best thing Woolworths can do? Sit. Because 20 is more than 10. If Coles sits, what's the best thing Woolworths can do? 30 or 20? 30. Woolworths will jump. Does Woolworths have a dominant strategy? No, because the strategies are not the same. Now we look at Woolworths jumping. If Woolworths jumps, what's the best thing for Coles to do? 20 or 10? 20. Coles will jump. 20 is more than 10. If Woolworths chooses sit, what will Coles choose? 20 or 30? 30. That would involve sitting. Coles will choose sit. Does Coles have a dominant strategy? No. Okay. You see why this one is not a Nash equilibrium. I'll start with Coles jumping. And it doesn't really matter where you start. If Coles chooses jump, Woolworths will choose to sit. If Coles chooses jump, Woolworths will choose to sit. Now you go to the line that said Woolworths sit. If Woolworths sits, what will Coles choose? They will choose to sit. Has Coles changed their original move? Yes. Because the original move was jump, then Woolworths sat, but when Woolworths sat, Coles decided they would sit as well. So Coles has gone from jumping to sitting. They've changed their move. So this is not a Nash equilibrium. Because Nash equilibrium is when you don't change your move. So that's not a Nash equilibrium. Now, Coles sits. Go to the line that says Coles sits. If Coles sits, what will Woolworths choose to do? They will choose to jump. And if Woolworths chooses to jump, you go to the third line. And if Woolworths chooses to jump, Coles chooses to jump as well. If Coles chooses to jump, you go to the which line? First line. And then Woolworths will choose to sit. If Woolworth sits, you go to the fourth line. Woolworth sits, Coles will choose to sit. If Coles sits, you look at the second line, Woolworths will choose to jump. If Woolworths jumps, you go to the third line, Coles will choose to jump. If Coles jumps, you go to the first line, Coles jumps, Woolworths will choose to sit. If Woolworths sits, you go to the fourth line, Woolworths sits, Coles will choose to sit. If Coles sits, you go to the second line. If Coles sits, Woolworths will choose to jump. If Woolworths jumps, you go to the third line. Woolworths jumps, Coles will choose to jump. If Coles jumps, you go to the first line. Coles jumps, Woolworths will choose to sit. What is the point I'm trying to show you? Do they ever reach a point where they don't change their move? They constantly keep changing their moves from our analysis. They constantly keep changing their moves, so we say that this game has no Nash equilibrium because they constantly keep changing their moves. Because the word equilibrium implies something stable. It's obviously not stable. I just stopped after an arbitrary amount of iterations. You could keep going tonight. Yeah, find a friend on the train and just keep going. Jump, sit, jump, sit, jump. Yeah. Don't tell them you're from here. So this game has no Nash equilibrium. And not every game needs to have one, right?